We have looked at isometric, we've looked at perspective, and now we're going to look at the last of the pictorials that we are going to cover, and that is multi-view sketching. The multi-view drawing shows two or more dimensional views of a three-dimensional object. What that means in simple terms is that it shows everything that's in a multi-view drawing is a flat, non-3D, two-dimensional representation of that 3D object. It shows the shape of the object, and then if you put dimensions on it, it shows the size of the object. And if you put notes on top of that, it then can show the material of the object. And with those three things, the shape, the size, and the material, you can have that made anywhere in the world. And this multi-view drawing is the main form of communication between the engineers, designers, manufacturers. Here is an example of a multi-view sketch. We have the chair, kind of reminiscent of when I worked for Drexel Heritage as a furniture designer. And you will notice several things right off the bat about this chair. We have the multi-view drawings. All right, we have the front, we have the top, we have the right side, and we have the left side. What this is showing is what this would look like if we looked at it straight on, only in 2D mode. And then what it would look like from the front, and we define what the front of it is, and it's the view that shows us the most detail, gives us the most detail, and has the least amount of hidden lines. So in this case, the front view shows us the most about the chair. So then from there, we derive all of the other views. Also, multi-view drawings can have isometrics attached with them, and you see the 3D version of the chair. It's part of the multi-view drawing, but it's also not part of it. The multi-view is all in 2D, and then we add the 3D isometric. So it's still an isometric pictorial, but we've added it to the multi-view drawing. So here's another example. This time it has dimensions. Once again, we have the isometric view that's been placed into the item, and that will show us that we have selected this face as the most, giving us the most detail. So that's why we've gone down here and put that in the front view. So the front view gives us the most detail about the object, shows us the most about its shape, and has the fewest number of hidden lines. Sometimes those rules can be broken, all right, because we have two hidden lines here, and it's really the only hidden lines in the entire drawing. So I see the hidden lines here and see the hidden lines here. So we broke that rule because when we look at it from the top, it's kind of blocky and doesn't look very much different from the side view. So the top looks very similar to the side view, and so the front shows us the most information. So remember that. And so there's the side. Multi-view drawings. I also, when I was in school, learned this as orthographic. Orthographic, basically meaning many drawings or many pictures, kind of like photographic is light picture. Orthographic is many pictures. So you'll notice that we have many pictures on the multi-view drawings. So all three-dimensional objects have a width, height, and depth. Width is associated with an object's side-to-side dimension. Height is associated with object's top-to-bottom dimension. And depth is associated with an object's front-to-back dimension. Very logical, very much common sense. If you need to write this down, do so you don't remember it. But if you can remember it, don't worry about it. Go ahead and skip it. So here we were going to generate a multi-view drawing. We have our wonderful isometric, and we have defined our front, top, and right sides because we have picked the front view as the most interesting view. It also has the least amount of hidden lines. Not that any of the other views have hidden lines. So I don't know why they're putting the top view in first. That's kind of backwards to me. I would have done that the other way. What they're trying to show you is that if you're looking down, straight down at the top of it, then you rotate it 90 degrees and then that becomes your front view. I personally like to look at it the other way. You're going to lay in the front view first, always, and then you're going to rotate it to the top view. So it kind of rotates the object towards you if you go from the front view. And then you can kind of see it rotate here to the right side view. And that's how you're going to lay it out for every single one of those. Okay, so if you have the part in front of you, you can roll it towards you to look at the top, or roll it to your left to look at the right side view. Once you get rid of those extra bits that was just there to show you how the part turns, now you have the three items: front view, top view, and right side view. This is going to show you a little bit more about the height, width, and depth, how it translates in the different views. So our height, you will notice in the front view and the side view, our height is the same. The same thing with our width. In the front view and the top view, the width is the same. And this is how you will structure these on every multi-view drawing or every orthographic drawing. Your width, all right, and your front and your top view, your width of the object are going to be in line with one another. Sometimes kids get the top view and then they move it over to the side, and it's not directly in top of the front view, and that is wrong. It should be lined up exactly. Same thing with the height. And then our depth is actually translatable via a 45-degree line from the depth of the top view. So it shows the depth in these blue lines to the depth of the right side view. So they're the same. So each view shows two of the critical dimensions: height, width, and depth. So orthographic projection, all right, it's a technique used to create multi-view drawings. Any projection of the features of an object onto an imaginary plane of projection. The projection of the features of the object is made by lines of sight that are perpendicular to the plane of the feature. Wow, that seems extremely confusing. Okay, and we're going to walk through that because that really doesn't make any sense. So the best way to understand orthographic projection is to imagine a box. All right, and you have a glass box, and you take an object and you put it inside the glass box, and the glass box has hinges. So here we are, we're going to put that inside a glass box. If you have a box, if you have a rectangular prism, then there are 6 glass walls that surround the object. Each wall is now a projection plane. Okay, so which you can now project a two-dimensional object onto each of the sides of the glass box. And this is something just to remember, to stick in your mind, to understand how to lay these out. So the projection plane, all right, so write this down. You may see it later, and it's in reality is you may see it on the test. You may certainly see it on the EOC, which I don't have any control out of because they want you to understand and use this terminology. But in reality, the reality is it will very rarely come up in industry. You're not going to talk about the projection plane. You're just going to it helps you understand multi-views a little bit better. But basically, it's that imaginary surface. It's the surface of your glass box between you and the object. So we got rid of all the other glass planes except for the front view, and so you're going to start by looking at only the front view. And if you move the object, if you hold an object right in front of your face, you can see, all right, that you can angle it to where you only see those 5 sides, and you cannot see the depth of the object. So that's what you want to do, either in reality if you have the part in front of you, or in your mind. You want to imagine or orient the object so you cannot see the depth of the object. So that you can see the 5 points. And then, and this is imaginary, this is in your mind. So you're taking those 5 points and you're projecting them onto the plane. All right, so the projection line, imaginary line that's used. Look, I'm not going to go over this. If you want to write it down, that's fine. But I think it really just confuses the issue. So you have the visible edges, all right? And this probably makes a lot more sense when you have it oriented that way. If there's an imaginary piece of glass, if you just take your imaginary pen or your actual pen and your actual piece of glass and draw on the piece of glass where you see the object. And so that's what you're doing in your mind's eye. You're ignoring the depth. It is not 3D, and you're just saying, okay, there's a line here, there's a line here, there's a line here, there's a line here, and there's a line here. So once you project that out, this is kind of what you get. You see it in green. And then you repeat it, okay? And if you have your glass box and you unfold your glass box, then you have these 6 multi-views. You have your front, you have your top, your right, you have your bottom, you have your left, and you have your rear. And you can see here. And this tells you everything you need to know about the object. Once again, we'll go over how to select the best front view because it's very, very, very important, and you need to know this deep down within your soul without almost conscious thought. Know how to pick the best front view. You must know that. In case you're missing my point, you must know how to do this because you're going to do it from now on through your entire career. You're going to pick for the rest of the time in this class, the rest of the time in POE and further PLTW classes, also into college and your career. You've got to pick the best front view. And the most important thing is to know that it's the most natural position to use. All right, it seems right. It gives you the most detail. It gives the best shape. It shows the best contours to show you the how best this in 2D, what's the best way to show you with a single view what the object looks like. A lot of times it'll have the longest dimension. A lot of times it will have the fewest hidden lines, and then like the most stable and natural position. Basically what that means is you're not going to turn it at a weird angle. Okay, if it has a long flat edge, that long flat edge, if you set it down on a table, that long flat edge is probably going to be the way you put it down, right? So we talked about this one before, but here's another example. So that we talked about what's the best, what does this look like? And if we look at what this looks like from the front, you get something that looks like this, right? And this goes down here. Oops, I went too far. But you see that. But if we look at it from the top, and I'll try to get these lined up like you're supposed to, but I'm, drawing with a mouse, so it's very, very difficult. All right, so we have this here, and then we have, oh my gosh, this is terrible. But basically the 3 views look like that. Those should be lined up. This should go through here, but I'm terrible with drawing with the mouse. And if you look at that, we kind of have the top view looks like a box. The side view looks also like a box, and then this one we can see, and this one being the front view, we can see that this one makes the most sense as the front view because it tells us the most about the object. Coincidentally, it doesn't have any hidden lines, and it has the longest dimension as well. One thing to consider is the number of orthographic projections. You don't always have to have 3, and the reality is it is best to have the fewest number as possible because the more drawings equals just more confusion sometimes. So if it's a uniform thickness or shape, you can give it 1 view. An example of this is where if you laid it out, it's a plate. You laid it out, all the 2 views would be identical. For example, if we were drawing a flat plate and it has a hole in it, right? If we did a top view, it doesn't really show us very much. If we do a right side view, all right, this view is starting to look identical. All right, we have some hidden lines here. I don't have things lined up. All right, we can get by with only 1 view here if we say that, material is 1/2 inch. steel, right? And then we could make this square part and say it's a ½ inch thick. We can call out the depth with a note, and therefore we could only do a one view. And so we have this piece down here. You'll notice that they have where they've called out 1/8 inch flat stock. So if it's of uniform thickness, all right, uniform thickness or shape, and the additional views would be identical, and you can show all the dimensions you need on one view, then you can use one view. Same thing here, okay? Now there's a critical part you don't want to miss here. We can't tell from this one view, is this one round or is it square? Because it would look the same, except for we notice on each of these dimensions we have a diameter call out. And so when we have a diameter call out, we know that this is round stock. So if we did a side view over here, we would see, ooh, that's not a circle. We would see, it wouldn't tell us very much, but we would know that this is round. We don't have to do this. We can get by with one view because we can use the diameter symbol in our dimensions. So for two views, we have a symmetrical part. All right, a third view, in this case the right side view, is going to look exactly the same. In that case, you're going to do two parts. Why would you draw an extra view if it doesn't make any sense? If I did a right side view over here, it would look exactly the same as what I have over here because it's symmetrical. All right, so we don't have to do this third view over here. We don't have to do it because it looks the same. All right, and this is most common on a symmetrical part. So the second view or the third view is not necessary. So you don't need two for the depth. So we're going to quickly walk through how to put a multi-view together. Given the overall dimensions of the object, a pencil, and the sheet of graph paper, sketching a multi-view drawing can be easily done using points, construction lines, and object lines. Remember, on your construction lines, a lot of you guys and gals are getting very, very heavy and dark with your construction lines. Your construction lines should be light, and they should not be able to be seen if you hold them at arm's length. So they need to be a lot lighter than most of you guys and gals are doing. So step one, if you want to write these down in your engineering notebook, you may. If you can go through this and you understand multi-view drawings to the point that you can do them for the rest of your life without having to think about it, then please, you don't have to write it down. So make the right choice, but we're going to start line by line and go through this and slowly build it together. Step one, lay out the boxes with individual views will occur using points and construction lines. You're basically going to outline the object. So we'll lay in our construction lines here. Here's top, here's the height, there's the width. Then we're going to move over a little bit and we're going to lay in the depth. We'll lay the depth in here. There should be a 45 degree. That line should probably come in first to show that you project up and then over. All right, but now we have the three views, top, front, and side. So that's number one. There's going to be your top, and there's your front, and there's your, well, kind of made it go away, but there you saw the three views. So step two, use construction lines between the views to indicate the geometry of the views. You're going to lay in, if you see the part over on the right there, you're going to lay in the other bits and pieces of the part that you can see in each of the drawings. All right, so this line here, we're going to lay it in with an object line. You notice that it should be a construction line. It should not go all the way across. It should stop at the edges. But we're going to lay in that line. It goes there. You can see it in the front view. You can see it in the side view. We're going to lay the vertical line. Notice that goes all the way up to the top. Anything that's vertical, you're going to project to the top. Anything that's horizontal in your front view, you're going to project all the way to your side view. And so as we go through this, you can see, I'll let you stop the video. You're going to identify the visible edges with object lines. So these are all construction lines, and now we're going to go back in and lay them in nice and dark. Okay, so now we have their edges. We're going to go over to the side. We're going to lay in our edges here. So more edges. Here we go. There's what it looks like from the side. We're going to move up to the top, add in our object lines, make them nice and dark. You're going to find the hidden lines. Step 4, find the hidden lines, drop them in. Remember, hidden lines are dashed lines. Ooh, I skipped that a little bit quick, but here's an historical example. When we look at this, we have the guy who's sitting inside a duck blind, so the ducks fly down, and then we blow them out of the sky and eat them for dinner. So here's the guy, he's sitting in the duck, and you'll notice that he has the views oriented incorrectly, because here's our front view, gives us the most detail. This makes the side view, and you will notice that these are not hidden lines, so he's actually got this turned backwards, and then this needs to move up to the top view where it belongs. All right, so he's oriented these incorrectly in space, and then he's turned them incorrectly. So be able to be sure to watch out for that as you build your own. So here's a final question for you guys as we wrap it up. When we look at these, each of these blocks at the right have the same overall dimensions and color. Look at the top views. All right, take a moment, pause the video, and tell me what the top views all have in common. And the answer is they all have identical top views. The top views for each of these objects are the same, and so that's why we have to do multi-views, because if we only looked at the top view of this, we would only see the same object, and they're all radically different. So that's one of the reasons we use multi-views.